Welcome back to the new lesson. Let's continue. In the last lesson, we saw that how we can create automatically a composite function block using NxtStudio's feature to combine multiple blocks into a new function block, or rather a composite function block. And we also saw that this is a problem because the standard itself does not allow you to connect multiple data outputs to a single output of the composite block interface. That's because the behavior is undefined, it's ambiguous, and it's left to the user who is designing or programming this to decide what should happen when you want to combine these two into this one. So that's what we're going to do in this lesson. We will create our own basic function block that not only merges the events but also merges the data. So in that case, we don't need this, so let's get rid of this. We will delete it, and let's rename this to something else so that we can rename our basic function block that we're going to create emerge4. So maybe I'll rename this to emerge4 CFB. Okay. So let's go to basic function block, new item, and we call it, like we said, emerge4. That means it's merging 4 events and data. Of course, we're merging data, so let's call it ed merge4 so that it's event and data, and it's merging 4 of those. Okay. Okay. Now, it of course needs the same interface: addition, subtraction, multiplication, division, and we have 4 inputs: add in, or maybe we can call it whatever they actually are. For example, sum input when you do addition of type int, then difference in when you do difference, and then when you do multiplication, you get a product, so you get a product in of type integer, and then division, you get a divided value, so we call it div in. Okay, now we need to get the associations right. All events will be associated within it. Like we discussed in the last lesson, we don't know if init is required. We will see. For now, we will keep it. So let's associate the rest of the events to init. Remember, you can also click here and associate input and output, events and input variables, or the output as well. So right now we're trying to associate subtraction, so that will be with diff. Multiplication will be with product, and division will be with divin. But let me show you the other way again. That is, you click on the input data that you want to associate, click and hold, and drag it over the event that you want to use, like that. Okay, so now you see that all the input data is associated within it, and then addition is associated with only sum, difference with diff, and so on and so forth. Okay, now we need to get our algorithms. Basically, we don't know what we want to initialize. Maybe we can just initialize. We need one out, so let's create that first of type integers. Okay, so we can initialize out to 0. So okay, that makes sense. Init will initialize the output to 0. Again, it does not depend on the input, so this association is not really necessary. We can keep it or not, it does not matter. Just because I want to show you how to associate or de-associate events at one shot, multiple of them. I will show you this. Since we decided that this does not matter, I'm not going to associate that within it. Okay, so now that is gone. So in the algorithms in the init, we just do that. In the request, we just, depending on the event, we need to copy that value, right? So we will have different algorithms for different different events. So addition, subtraction. Again, remember that to add a new algorithm, you don't click outside of the space, but you actually right click on one of the algorithm tabs. Okay. Multiplication. And finally, division. Okay. So in case of division, out will be equal to div in. I'm going to copy that. Same thing here, but this will be prod in. Similarly here, this will be div in. No, it should be subtraction, so it should be diff. Diff in. And then for addition, it will be sum in. Okay. Now we need to get our ECC right. Now, if you're wondering, we could have just renamed this. If you go back to calculator, we doing exactly that, but in the algorithms, instead of adding, we're just copying them. All right. So you could actually have, to save some time, you could have gone here, done a copy, and then a paste, and it will ask for a name, and you could have given that and went ahead and just changed the algorithms. The rest of the structure remains the same, but we want to practice a lot at this stage, so we will do it, all of this manually. Okay, so init remains as is. This will be on this side, so let's call it division, and this will not be required. Instead, it will be division, and this algorithm will be division. Okay. Similarly, we need more state for addition. Let's take this init back here so that we have some space here. So addition goes here. Subtraction is here. And finally, multiplication. Let's add action, addition, CNF. Action, addition, CNF. Action, multiplication, CNF. You already saw that. I made a mistake. So let's change that. It should be subtraction. And now addition. Then we go back. Subtraction. And then to transition back. Multiplication. Then to transition back. Perfect. Now we have both a block that merges both event and data. Before ending this, let's just go ahead and use that basic function block in here. Okay, and this one will now get connected here, and addition, subtraction, multiplication, and not that one, this one, division. Okay, and this one is sum in, this one is difference in, this one is product in, and this one is division in. Okay. Since we did decide to use init, let's connect this init over here. Let's take this there. And let's do that here. And then we connect the CNF as is. Okay, so that's all in this lesson. In the next lesson, we will test it and see if our logic and design works.